like that. Bring up the procedure document. Project 2. So this one's going to be fairly simple. Really good news for us.
I was about to say also.
Yeah. Oh no! Look, it is fairly simple. Because once you do that, this is not being so simple. Once you've done that first one, then there's a lot of recycling that go on, and there's not a huge jump for this one beyond what you've already done. But I've just got to get it. Yeah, okay. There we go. Sorry. Thank you. Oh, yes. Yeah, project 2. Building. Okay. So the reason this one is simple is because you've covered a lot of these things in planning approval already, and then you've also done some aspects of this in building approval project 1. So first bit, develop models to meet requirements of natural ventilation, natural lighting. So that's fairly straightforward in terms of adding onto your door and window schedule how much ventilation and lighting is happening per window as a percentage of the floor area. So that's really simple. Natural lighting has to be 10% of floor area, ventilation 5%, and then for any shared lighting, etc., it's half of that. Once again, so that's very simple thing to express on your plans. Materials, so that's something you've covered in planning approval already anyhow, and we're not using any materials. Well, I don't think either of you or anybody externally are using any materials which are going to be a problem for this anyhow. Yeah, so once you mention the fire resistance levels for the walls, that's it, and as long as you're not using combustible materials, then we're all quite fine. Demolition, I think quite across, and you're doing that for planning approval anyhow, so nothing extra to add for that. And then addition of class 10 garage, so the enclosure of that bottom space, there's no real constraints that arise from that. So, and then these, we can skim through this fairly quickly because there's nothing much new in that. Then getting on to details, so detail all aspects to be supported in detail sheets and reports provided. Specific clauses for wet areas, so show your wall linings. That's about showing what is water resistant, what is waterproof. So, say water resistant plasterboard, the water resistant sections, and then you show which bits are waterproof. That's all fairly simple, and much of that can be recycled from project 1. Okay. So that's all fine. Wall and floor water resistance, waterproofing requirements, type and heights. The only difference between this and project 1 is with this one, we can't have a shower screen, we can't have a set down, we can't have a hob in the floor. So it's about showing the extent of waterproofing from that shower rose at 1500 because it's an open shower. You may or may not have done that with your waterproofing detail with project 1. You did that. You did an open shower with project 1. So this is really quite simple. The only thing I would add to this though is that's the basic requirements that you have waterproofing to the floor for 1500 from the shower rose. But being a disabled wet area, I think it's best to simply waterproof the whole floor area because there's no separation, and also you have a shower which is on a 1200mm long hose. So for all disabled bathrooms, you have that shower on a hose. That means that at any point in time, somebody can be further away from the wall. So we've got 1200 millimeters before our 1500 starts. Legally, you don't have to do that, but
It's good practice.
yeah, it's good practice because particularly in disabled bathrooms and so on, you have situations whereby there's washing and things required that is not happening in the shower.
Mhm.
So I think it's best practice to go above and beyond with your waterproofing in that regard, and also in regards to floor traps and things like that. What you can do in this bathroom is you can grade the whole floor to the shower trap. That's fine. That will work. It's possible, but it's probably better practice to have a separate floor trap and a separate shower trap.
Okay.
That's my phone. Might want to turn that off actually. Oh no, it's turned it to so far. I'll return that later. I think I know who that is and what it's for. Okay. Then installation of puddle frames. That's all quite simple and straightforward. And then tiling. That's to show which section is water resistant, because for on your walls and floor, it's not just the situation of having waterproof plasterboard. You actually have to have tiling on that section as well. So show your tiling to that extent. Then that's quite simple. The other thing you might want to add in your cross section and your details are all of the disabled compliant aspects of that shower as well, including the seat, the shower rose on the hose, etc., which you can get from that website that's on product information one I mentioned earlier. And for those watching at home, so listed in product information, there's a website with links to CAD and Revit families of all disabled compliant aspects.
So for the bathroom, I
So
can
it's-
do. Oh, sorry, I
Yeah,
stopped
yeah,
you.
yeah.
I can do like 4 views or just 2 views to show like the tiling, the hose, heights. What do you recommend?
Yeah. So just the 2 views
Two
will,
views?
yeah, definitely suffice. I don't see, that there's any,
Okay.
yeah. I think, it'd be very easy to include all those aspects in 2 views,
Okay.
possibly even in one, but yeah.
Yeah, because I was thinking my bathroom, like
Mhm.
the shower and the toilet was in front of each other. So
Okay,
I
yeah,
might
show the
take
2
into-
views,
yeah,
yep, split it up. Then next section, stairs. So cross section of stairs with compliant aspects to be clearly detailed and supported by specific clauses from the NCC in regards to goings, rises, width of stairs, height of railings. You've covered all this in compliance. It should be really quite simple. The only thing that you really need to be aware of is that we're not in Volume 2 NCC, it's Volume 1 NCC. So you'll have to change your references accordingly. Also with Volume 1 NCC, go in there and we're looking at a public stair. So it's slightly different constraints on the rises for that as opposed to a residential stair.
Okay.
So you're allowed to go, I think a taller riser on that. But that should be fairly straightforward. Go into the NCC. Volume 1 was, I can't remember the name of the section off the top of my head. Then lift, cross-section lift with compliant aspects to be clearly portrayed and supported by specific clauses from NCC. That's all fairly straightforward. So AS 1735.12, and in there you get all of the information about lift height, buttons, door clearances, car sizes. The bit that will be a bit of work and is all new is plumbing passing to ground level. So yes, we're not plumbers. We don't typically do plumbing design. So you quite often get a plumber to do the design, or other engineers that would be doing that water. But the reason we get you to do this and to work through AS 3500.2 is because it is a fairly important thing from a design perspective to be able to understand that the runs of plumbing and where plumbing needs to go, because what you really want to minimise is any delays or having to work things out on site, or having plumbers saying we can't actually run this pipe through here, you haven't allowed enough for it. Now with this project it's really simple, because we've got all of our bathrooms at the back, or our kitchens close to the back, and then our bathrooms, and then we've got free space underneath. At worst, we can run plumbing straight under the slab in the car park, and then we just box that out with fire-resistant plasterboard to ensure that it's not a passage for fire coming up through the pipes if someone's car is burning or something like that. So it's super simple for this project. We really wouldn't have to typically go working out those plumbing runs for this type of project, but it's good exercise to do it on a really simple project like this, to be able to get your head around it for thinking for projects where you might have to be working it out and specifying and thinking about those things initially. So for doing that, we have to refer to AS 3500. And well, first of all, so cross-section of building showing passage of pipes from wet area to ground level, and then show on ground floor plan where vertical pipework is to be located in garage or elsewhere. So that cross-section, and then showing on the ground floor plan where it's meant to be done. What I've also had other students do is actually produce a separate plan, rather than using the ground floor plan where you've got all your car park and everything like that. It gets quite busy. Actually produce a separate plan. So have a page for those plumbing details, and then show that as another plan. Whatever works for you, works for your layout, and shows it clearly. Okay. So what you're going to have a look at is AS 3500.2. So I'll have to. Thought I had that open. I'll get it open again. Excuse me. So building compliance. Compliance. There we go. So there's a whole heap. So there's 3500, 0.133, etc. for different aspects of plumbing. So 3500.2 is for drainage. And also what we want to have a look at is some plans that show plumbing. So this is for our project. This is a previous student's work. She's a fairly good one to refer to because her husband is a plumber. She did the drafting for her husband, so did all the plumbing drafting for him, so she knows it quite well. And then also she was a disability carer, and so this is the project for her basically. Okay. And she's done some fairly clear plumbing for that. But then there's so I will just scoot in so we can see certain aspects. So what has been done, and this is what I'm expecting to be the mainstay of your layouts, is that we're bringing the kitchen and the hand basin into one, and we run that to what's called the floor waste gully in our bathroom. That's the grate that you'll see in the bathroom there. So there's a separate floor waste gully rather than the shower. As I said before, it is possible to run everything in your bathroom to your shower, but this way it enables you to bring in all these fixtures into that one point for if there was any blockages or so, then it can come up that floor waste gully. And this is typically what's done. So you bring your fixtures into that floor waste gully, and then we come and join up to the main drain after the toilet. So our toilet, and she's got different sizes of pipes on here, and we'll have a look at that in a minute. Our toilet has to be a 100 drain, so a 100 diameter drain, and then also our main drain coming from that toilet has to be a 100 diameter drain as well. So it comes out of the toilet as a 100 into the main drain, which is still a 100, but then we bring our other drainage into that main drain after the toilet. Then at that point, because we've got all those things coming in, that's a really good point to also have an inspection opening.
Okay.
So got an image here of an inspection opening. So that's what we're going to be looking at with an inspection opening. So that to me appears to be a 100, like a main drain size. So that's where you screw off that cap, and the plumbers can get in there and do the inspection. Now, you don't have to have an inspection opening at the toilet and where you're bringing everything together, but it is a really good place to do that.
And
So
this goes on the floor or at the
you want that. You can have, it's possible to have one of those inside the building, so they can, that if you've got a pipe running horizontally, it can be in that pipe running horizontally. You don't want to have one of those in your floor of your bathroom. It's particularly ugly, and typically you don't include them inside a building. Certainly in this building, you'll see them. There's one there on that. So they're in inside this building, but typically for a residential, you include them outside, and it's really quite simple to include them outside in this project because you've got two options. Now, actually, I'll bring up another plumbing plan as well. So this is from another student. This fellow is a builder, so builder with plenty of experience, but one of his mates was a plumber, and they sat down and did this together as well. So completely different plumbing design to what Mary had done, but what he's chosen to do is run all the plumbing underneath the building. He's only shown an inspection opening here. I think it's much better to include inspection openings more regularly along your.
For each unit or?
I think at every toilet.
Okay.
Because you have to do an inspection opening every 30 metres, and so you can still do this, but what it means is if somebody's got little kids that stuff a toilet, like a fluffy toy down a toilet or something, then this is your nearest inspection opening, except for going through the pan of the toilet or taking the S-bend out. So, for those type of situations, I think it's good to include an inspection opening. Now that can actually be done underneath the floor because you've got your toilet coming out into your main drain, and then it bends and follows along the floor, and you can have an inspection opening as a T-piece off from there. As you'll see around this building, if you look around here, you'll see some 100mm drains about the place, and then you'll see that it'll come down, it'll T, and one end of the T is an inspection opening on the end. The thing I do like about this plumbing plan is the really clear legend here. So showing FW for floor waste gully, IO for inspection opening, V for vent, ORG for overflow relief gully, and then in the shower, toilet, etc. So what we'll be looking at, what we'll have to include in our plans are all of these things. So you'll have, if you're having a separate floor waste gully, which I recommend for this, you'll have those in your in your bathrooms. There's no issue there. And then inspection openings, we know about inspection openings now. Vents and overflow relief gullies. Every plumbing system will have to have an overflow relief gully. That will happen outside the building at ground level. Technically, an overflow relief gully has to be 150 millimetres below finished floor level. With this building, that's super easy to achieve because we've got our first floor up 3 metres high in the sky, and we can include our overflow relief gully down low on the ground. What that overflow relief gully does is that if there's any blockages or backing up or something happening with that sewer main, or if it's a septic system, same thing, if there's a blockage further down the line, then people can flush their toilets and it will come up outside rather than inside the building. And I've got an image here of an overflow relief gully. That's that thing there. So you've probably all seen one of those around. Yeah, and that's a fairly good detail because what you see with that one is that overflow relief gully is actually higher than everything around it. And that still has to be 150 millimetres below finished floor level. What quite often happens with overflow relief gullies, which is not a very good detail, is they get set down on the ground, and then people do their paving around them, and you've got this sort of height, and then that paving's about level with floor level or something like that, and so there's still that impetus for things to come up out of your floor waste. So I showed Kevin's plan fairly well so that's anyhow, you'll see that on the video if you want to stop that and have a look. That's good. I'll make it slightly larger though, in order to have a bit better look at everything. So he's included the overflow relief gully here outside. Then an inspection opening just there. And one thing, now where his vents? Right, so what he's done is he's vented the system here in the middle of this wall. So for all of your plumbing stacks, you need to have a vent at the head of that plumbing run. That vent ensures that you maintain water in all of your traps. And so for P traps and S traps, and I've got an image of one of those. That's this piece of piping here. What that does, that maintains a water level inside there. So it has an airlock. Because if we didn't have that airlock, then you get bad smells happening from the plumbing, and it travels back up through the pipes into the house. If you create this water lock here, ensures you don't get bad smells. But if this plumbing stack is not vented, then water going down the pipes can actually suck all of the water out of your trap, and then you just keep getting dry traps all the time. So you have to have a 40 mil vent at every 10 meters, but at the head of every plumbing run. So what Kevin did is he included a vent within the wall here. So that's possible, but I don't think that's the best detail. It works well for this plumbing run because his plumbing run his main drain is going through here. But if you're going to be running your plumbing outside, then you can run your vent outside. It's going to be so much easier to install, and it's going to be simpler to have more vents as well. So what Mary has done is she's put a vent. She's broken it up into two separate plumbing stacks. But I'll zoom out from that again. we have this plumbing stack here with a vent to that one, venting that, and then we have these two plumbing stacks coming together at that main drain and venting there for that one. So that's going to be the, I think that's the better detail to bring it all to the back of the building.
Yeah, but because we are so close to the boundary, in case I don't know something happened with the pipe outside, we be hard to fix it.
That's a good, yeah. Actually, that's a really good point. Yeah.
Because now we have only the tennis court at the back, but if something going to be built in the future and it's close to the edge, we're not going to have space to maintain the pipe. So
actually, that is a really good point. I think if you were to be running all of your plumbing, so you've built your walls, you've enclosure back into your carport a bit to give yourself space for accessing that area at the back. If you were to include all of your plumbing within that space and under the floor, that should be.
That's what I was thinking.
Yeah.
Okay.
So I think that's good to run it in under the floor, but to the outside side of that wall, so it's protected for, if there's a car fire or something like that. But it's really still quite accessible. It's outside of view and you don't get much noise from it. Yes, the only problem is then the logical place to run your vent pipe would be up that outside back wall. Yes, you've only got 500 mil space to access that, and if something went wrong or something, it's going to be difficult to access. But it's also going to be difficult to access if you're running it in the middle of a wall as well.
Yeah.
Less likely to get damaged if it's in the middle of a wall. If it, going through the middle of a wall, what's going to happen to it? Probably.
Just prevent part of that item so it's very less chances to get something like this.
Yes, well,
It's all simple like that.
It is. That's right, and it's a very simple pipe. So, whichever you choose to do, I think would be good. But that's really good thinking about access for when things need repair. So that's So the main things we've got to think about there is whether we've got space and so on, which is not a big thing for this project. We've got plenty of space on the floor. We have to think about protection from fire, because it's a fire source. It's a source of spreading fire through that concrete slab, and then we have to think about access for repair and also protection from vehicles and getting bumped and things like that. Because you've set your walls in that bit, it's just really easy to run your main drain down that. That's not a consideration. If you weren't building walls to enclose that rear section, you'd have to protect your pipes somehow from impact damage as you bring them down. So what Kevin did, he ran it all the way to one side and brings it down there, so it's clear of the car park. It's not going to get any impact damage. Another way to do it is to run your main drain down next to one of your support posts. So run it there and then box it out as well. It's supported. I guess it's still a bit. It's more vulnerable than any of the other options, but it's less likely to be hit if it's on a side of that post where vehicles aren't coming toward it. So the next bit to do then is have a look at AS 3500.2, and there are some sections. Have a look at that. Well, actually, I won't go through the whole of the standard. I'll go through a couple of things. So, the overflow relief gully has to be within 30 metres of the start of your plumbing runs. So we have to do that. And we've covered P-traps, etc. One thing we will want to have a look at is page 166. So I'll go down a little bit further. 165. So 166, section 13, fixtures and appliances. So there are, what we can do with the stand is size up the pipes with water flows and slopes, etc. We're not going to do that. That's for the plumbers to do. But what we can do as a very simple guide is that in this section, section 13, you have sizes given, standard sizes given for various different fixtures. So let's say we're doing an autopsy table, not that I expect you to put an autopsy table in, but we would have a untrapped waste pipe no smaller than 50 millimeters going to a gully of no less than 65 millimeters. So internal diameter of 50 going to a 65 internal diameter gully. So basins, hand basins, that's something we will be doing. So 40 millimeter internal diameter pipe running from that. And then bath, so untrapped waste pipe no smaller than 40 mil diameter. So we can get all of our pipe sizes from that, except for our main drain. Our main drain is not mentioned in here. I've got, section 3.32 covers the main drain size, but put really simply, it's 100 millimeters. So, and then you can also go to, not that you have to do that for this project. So this project is super simple. We've got plenty of space around our pipes, but if you were to have to size up, work out what slopes, you can go to this one. What is it? So on page 21, I'll make sure. So page 21. This one here, minimum grade of drains. So we've got our plumbing sizes and then our minimum grades to work out if we're able to pass a pipe through the web of a truss, for example, also, rather than go chopping the bottom quarter of a truss or working these things out. And then, that's fine. Those vents can be run through a wall with a 50 mil pipe. Covered that. And then I've got here in the notes, page 32, plumbing design. There's an additional to look at for 32. So on page 32, it gives you some guidelines in regards to some of the things I've spoken about already about the location of vents and overflow relief gullies, etc., and some sizes for pipes. So it gives that overview to it. How do you guys think about that? Do you feel fairly confident in doing the plumbing?
Yeah.
For this building? Yeah, it's a very, very simple one.
With confusion regarding vent pipe.
What's that?
Vent pipe.
Yeah. What?
Yeah. How to connect with main pipe, with vent pipe, or how do you?
I don't know actually. That's for the plumbers, but I'm fairly sure it'll be that you've got your 100 mil pipe, and then you've got your 50 mil T piece off of that, and then your vent pipe goes up. Good question. Yeah. Yeah, it'd be some sort of reducer from 100 mil through to 50, whether that's as a T piece or whether it's a little piece coming off on an angle. Also, the other thing is your main drain is going to have to sit down probably around 150 millimeters lower than any of the pipes that are coming into it as well, because they dip down at 45 degrees to come into your main drain to ensure that there's nothing coming back.
Mm-hmm.
Yeah, but yeah, once again, this project,
Yeah, we
that's,
have
yeah,
plenty of space to work with.
we've got plenty of space to work with. Yeah,
It won't be a concern.
no, it's not a concern. Cool. And then that's fairly much the main considerations. Anything new for this project you're gonna have to be thinking about. So there's that procedure document there. So I'll just go through the rest, but it's fairly simple. So door and window schedule, natural ventilation, etc. That's fine. Yep, that's all. It's all covered in there. So that should be yeah. So
Fairly less work than the previous one.
yes, and you can copy a lot
Yeah.
of stuff. I think yeah. Well, get that knocked off. I think get all the planning stuff happening as much as you can before the break. You can get this one done and peer checking for this one done fairly quickly, because you probably want to spend the bulk of your time on project 3. So it's good to be giving that one plenty of time. But you guys, fairly well set. Cool. Thank you. Better stop that.